Ever since Albert Einstein developed general relativity, it has been indicated that the universe is expanding. Even he was reluctant to believe this until evidence was detected by the Hubble Space Telescope. Thus, the Big Bang Theory was born. It reflects much of the evidence we find in nature, but the Big Bang Theory is not without its problems, and each problem seems to garner a unique solution, if a solution to a given problem is even possible within the framework. Some of the main issues which the general theory has encountered are questions like, what caused the Big Bang? Well, the physics breaks down at the Big Bang, and traditionally no answer is given. Shouldn't there be a contraction to balance out the expansion? A question rarely considered, and one to which few solutions are offered. What caused inflation? A mysterious event indeed. Here, quantum solutions of fundamental force decoupling as the universe began to cool are offered. What caused accelerated expansion to begin some 7 billion years ago? Dark matter is suggested, but is it just another ad hoc solution? And what happened to all the antimatter? Is baryon asymmetry really the answer? And how could the universe have emerged from an all-inclusive singularity if the space the galaxies are expanding into is already infinite? The relative flatness of space is a real problem for a finite beginning, which implies curvature. With issues such as these, one may well ask, how will the Big Bang Theory ever emerge from the cloud of uncertainty? What if there was a modified version of events that was still consistent with the data and at the same time capable of answering, or at least pointing in the direction of answers to all these questions simultaneously? Enter Watson's alternative Big Bang theory, which we herein refer to as WAB. We can also call it tent theory, or flat universe theory. The initial term coined just after December 21st, 2012, was the omniversal star, so named because this theory attempts to incorporate the multiverse into the framework. However, in this video, we will not be focusing on any extra universal mechanisms, but only on the advantages of WAB over the current model and its motley collection of solutions. Thus, herein, we will learn about WAB somewhat indirectly by introducing its solutions to the problems with the conventional Big Bang theory, thereby revealing WAB progressively by contrast. The advantages of WAB include 1. Extends prior to the moment of the Big Bang and gives a catalyst for the reaction. 2. Gives a practical explanation of universal expansion. 3. Directly addresses Háromény's concern about an expansion-contraction trade-off. 4. Gives a physical mechanism for inflation. 5. Gives a physical mechanism for accelerated expansion. 6. Provides an explanation for the location of all the antimatter. And 7. Offers a reasonable solution to the flatness problem. Contrary to the notion in conventional Big Bang theory that nothing existed prior to the Big Bang, not even time, in WAB the pre-Big Bang system was an open system capable of time arrow violation, that is, localized entropy reduction. When the system became closed, the thermodynamics of a closed system began to take effect, and so the closing of the universe was the spark that caused the Big Bang. The drawing up of energy is something akin to the buildup of spring potential, in which, once the system is closed off unto itself, the hold, as it were, is released, and the universe then seeks to return to the equilibrium position. Unlike the conventional Big Bang theory, Webb makes the counterintuitive claim that the Big Bang singularity was not all there was, but merely the tip of the iceberg, the apex or flashpoint of a system that was already fully extended and at its maximum volume at the moment of the Big Bang. A finite, albeit massive volume with an infinite surface area. The expansion of matter, then, is not simply happening alongside the cooling, but rather matter is expanding into the space that is already there, as the universe attempts to equalize what began as an immense temperature differential. As in the conventional Big Bang theory, when we assume that there is nothing outside the universe, we make a crucial oversight concerning the need for a balancing reaction for every action. As a consequence of universal expansion, there must be a reaction that is giving way to the expansion. Nassim Haramein was aware of this and has suggested that every point in space is spiraling back down towards singularity. Having produced Webb independently beginning in late 2012, this balancing of action-reaction in universal expansion is inherent in my model. I had an answer before knowing the question, and much to my satisfaction, I later discovered it was a principle which I was not the only one to have seen as important. Far be it from me to at this time provide a rigorous description of inflation. We simply point to the fact that there are two kinds of motion to consider. One, the motion of objects relative to each other, and two, the expansion of space itself, which causes objects to appear to move. Webb asserts that while the matter in the universe seeks to achieve thermodynamic equilibrium, the space in the universe, particularly where most of the energy was stored around the Big Bang singularity, experienced a great and brief smoothing of curvature immediately after the moment of universal closure, making it appear as though matter was slingshotted out into space as it depressurized. Instead of dark energy as the cause of accelerated expansion, what if there's a simpler explanation, again involving the structure of the universe itself? Webb asserts that accelerated expansion follows from an inverse relationship between universal expansion and universal volume. As the volume of the universe begins to decrease to a critical point around 7 billion years ago, the squeezing effect on space causes galaxies to appear to speed up away from each other. Prior to this point, there was no acceleration because the galaxies still had room within the main chamber to spread out normally. If the universe had stopped decreasing in volume beforehand, there would have been no acceleration, but since the amount of room is continually constricted, the space, and thus the galaxies themselves, are made to spread out more and more. I'm not saying that dark matter or energy don't necessarily exist, but I look at Webb and I see what appears to be a very versatile and holistic approach. The recipe for a universe includes, but is not limited to, equal parts matter and antimatter. So where did all the antimatter go? Algebraically, we know that whatever operation is done to one side of an equation must be done to the other side in order to remain balanced. To get something from nothing, we simply add one and subtract one, hence the virtual pair. In Webb, the matter and antimatter emerge as virtual set pairs from opposite sides of a planar boundary which functions as the equilibrium state. In Wab, we do not wonder where all the antimatter is, but whether the boundary separating us from it is permeable. If it is, then matter and antimatter galaxies would be able to collide. And again, we see that Wab offers a macroscopic solution to a macroscopic problem, with the striking implication that the universe as we know it began in a dual Big Bang system. And, as previously indicated, Wab provides a solution to the flatness problem, which is that the Big Bang predicts curvature, but that space is measured to be flat within uncertainty. Wab says that the curvature is there, it's just too slight to measure. Sort of like being stuck on the Earth and perceiving it to be flat with no other frame of reference. Perhaps curvature could be detected in the early universe, however the greatest curvature during inflation would have smoothed out long before the emergence of the cosmic microwave background radiation some 400,000 years after the Big Bang, so there'd be no way to use light as a frame of reference during this period. Wab shows how the universe can be essentially flat now and at the same time have had extreme curvature at the beginning. Thus, Wab indicates that the universe is infinite in surface area and finite in volume, possessing what is now a roughly flat space-time geometry. In the compiling of this work, I must admit, I was surprised to learn that someone else has had a similar idea. In his book, The God Problem, published in 2012, Howard Bloom outlines his vision of a toroidal universe. The first thing to note is that although it may be a slight stretch of the definition, Wab is rather an inverse of Bloom's model, and so we coin another term for Wab, the inverse torus. Speaking with respect to the advantages Wab claims over the traditional model, and though Bloom's model appears similar to the inverted torus, it is clear that Bloom cannot make most of the same claims. His model is not even spatially possible, as there is no internal volume, and everything must rest on the surface of the torus. There is no balance of expansion-contraction. The torus is fixed, so there is no way to account for inflation or accelerated expansion, though he attempts to claim that acceleration occurs for no apparent reason once galaxies pass the top and begin descending towards the equator. It does explain the location of all the antimatter, if we accept that the antimatter expanded in the opposite direction of matter from the same point. When the matter and antimatter collide along the equatorial region, Bloom claims this sparks the next Big Bang, though this makes no sense given the fixed shape of the torus. And again, the curvature is fixed, and yet space is observed to be roughly flat. Therefore, Wab remains a viable alternative, while Bloom's model does not, to say nothing of his claim that his model precludes the existence of God. Thus, I have attempted to show how rather than looking for individual solutions to each problem, a modification in our assumptions may be able to resolve a whole host of issues, and at the same time give us an even greater insight into the nature of our amazing universe. That's it for this presentation. Please like, comment, subscribe, share, and if possible, make a donation. I would greatly appreciate it. Thank you for watching.